Greetings all of you. Let us look at question 16, trigonometric equations. Now here we are told to show that if sine x plus alpha is equal to p sine x minus alpha, then tan x will be equal to that. So the idea here is that we are going to expand this using compound angle formula. But now creating a tan, that means we need to divide by a cos. The sine over cos gives you a tan. So let us see. Now when we expand this, we are going to have sine x cos alpha, then plus sine alpha cos x equal to p into the right hand side. When we expand it, we shall get sine x cos alpha minus sine alpha cos x. So removing the bracket, I have sine x here, cos alpha plus sine alpha cos x equal to p sine x cos alpha minus p sine alpha cos x. So now what I'm going to do is to divide all terms by cos x cos alpha. The reason I'm doing this, I want to create a tan. So cos x cos alpha and cos x cos alpha, because when you look at here you have a tan alpha and you have a tan x. So whenever you have sine cos, just divide with the cos and get rid of the sines, because that will transform them to tan, to tangent of the angle. So let us see. So from here, this cancels with the sine, the cos cancels with that cos, so we remain with sine over cos. Here we shall see that this cancels with that. Here we shall see that cos alpha goes, and here we shall see that cos x goes. So let us now find what remains. We have tan x plus tan alpha equal to p tan x, and here minus p tan alpha. So collect like terms. I'm going to get the tan alpha on the same side, so we shall get tan x tan alpha plus p tan alpha equal to p tan x minus tan x. So when I factorize tan alpha, I'll get p plus 1 equal to, when I factorize tan x, I'll get p minus 1. So here I make tan x the subject. I'll have to divide with p minus 1 on the left hand side, or this term here will be divided by p minus 1. So this is going to be p plus 1 over p minus 1 times tan alpha, and that was our struggle which we have attained. So now after here, let us now go to the hence part. Now the hence part, we need to start from where we have stopped. So this hence part, we can see that tan x is equal to p plus 1 over p minus 1 tan alpha. However, if we compare what is given here with what we had in the question, x plus 20, here I have x plus alpha, x minus 20, here we add x minus alpha. That implies that alpha is 20 degrees. Then p is appearing on this right hand term part, which is p times sine x minus alpha. So here we have a 2, meaning that p is 2. So we need to substitute. We get tan x to be equal to p, that is 2 plus 1, which is 3. P minus 1 is 1. Then tan 20. So we get tan x as, let us check from the calculator. So tan 20 times 3, we get 1.09. This gives us 1.09. So what is the tan inverse of that? So if we get the tan inverse, tan inverse of 1.09, you get 47.46. X is 47.5 degrees. And now we have a range from 0 to 360, but we need to look for the interval where, the quadrant where tan is positive, which is here and here. So put the angles there. Then we move from here up to here. This is 47.5 degrees. Another angle will be this, that is 180 degrees plus 47.5 degrees. So our x is going to give us 47.5 degrees. Then when we add that, that's 180, we get 227.5. 227.5 degrees. So these are the solutions for x. So thank you for watching. Let's meet in other videos.